Alright, today we're going to talk about solving two-step inequalities. And to do this, it's very similar to solving equations. We work in reverse order of operations, and we do the opposite operation or the inverse operation on both sides of the inequality. So let's start off with an example here. So when I'm working in reverse order of operations, I'm looking for subtract and add. So first, we've got this. If we rewrite this inequality, this can actually be written as 7 is less than or equal to negative p minus 3. And since we're trying to get the letter by itself, this would be the first operation that we start with. So instead of subtract 3, we're going to add 3. So 7 plus 3 is 10 is less than or equal to negative p. This cancels out. Now, we want to have just p by itself, not negative. So in order to get rid of that, we have to divide by negative 1. But here is an important note. Anytime we multiply or divide by a negative, we switch the inequality symbol. So that is very, very important. Every time we multiply or divide by a negative number, like we're about to do right here, we have to switch the inequality symbol. So now 10 divided by negative 1 is negative 10. Instead of less than, it's greater than or equal to. And this cancels out, so it's p. So negative 10 is greater than or equal to p, which is also p is less than or equal to negative 10. This makes it a lot easier to graph if we put it with the letter on the left side. So now I can graph my solutions on a number line. And we're going to say this is negative 5, negative 10, negative 15, and so on. So first we're going to circle negative 10 because that's the number in our inequality. Then this arrow over here matches with this arrow, so we're going to color this side in. Since it's equal to, I can also color in this circle on negative 10, and I'm going to connect the arrow and the circle because I need all the numbers less than or equal to negative 10, which would be over here on the left side. Okay, let's try another example. Here we've got 8 minus j is less than 2. So first I need to move this 8. Since it's a positive 8, I'm going to subtract 8 on both sides. These cancel out. I've got negative j is less than negative 6. Now I need to get rid of this negative again, so I'm going to divide by negative 1, which means we're going to flip the inequality. So now I've got j is greater than 6. If I put that on a number line, I'm going to circle 6. Since it's not equal to, we don't color it in. This arrow matches the one on the right over here, so I'm going to color that side in. And I'm going to color all the numbers that are greater than 6 because j is greater than 6. Okay, let's try another one of these. 7 minus c is greater than or equal to negative 1. I want to get c by itself, so I'm going to subtract 7 because this is a positive 7. Cancels out. Negative c is greater than or equal to negative 8. I divide by negative 1, which means I have to flip my inequality. C is less than or equal to 8. And on a number line, Okay, so we would circle 8. It's equal to, so we can color it in. And this arrow matches the left arrow, so I'm going to color the left arrow in. And I'm going to color in all the numbers that are less than or equal to 8. Let's try one more of these. Alright, 2k minus 67 is greater than or equal to negative 49. I want to get k by itself, so I work in reverse order. I'm going to look at this minus 67 first. The opposite would be to add 67. So we're going to add 67 to both sides. So now I've got 2k, this canceled out, is greater than or equal to negative 49 plus 67 leaves us with positive 18. And then my next move would be to divide by k because it's or divide by 2. Then over here we've got 2 times k, the opposite would be divide by 2 on both sides. This turns into 1k is greater than or equal to 18 divided by 2 is 9. So k is greater than or equal to 9. And then on a number line, okay, so we'd circle 9. It's equal to, so we can color it in. And then this arrow here matches the arrow on the right, so we're going to color this one in. And we're going to color all the numbers that are greater than 9. And that is how we solve two-step inequalities.